This is Bryce Manley, and I agree for this video to be publicly available. Alright, so my project was on machine learning for author identification, and basically what that means is that I have a large data set of blogs, and I took one blog almost at random, and I took the first part of that blog, and I fed that into machine learning algorithm, and I compared it to that blog as well as several other blogs to see if my algorithm would be able to identify it. Alright, so what is machine learning? So machine learning is really made up of three pillars, kind of. So the first one, and the one I spent the most time on, is a decision process, a prediction or classification of based on data. And you'll find that data and data science and having good and robust data is extremely important for machine learning in general, and especially for this project. And the next part was an error function. Basically, that's kind of just training your model in a way. It's having some known quantities, some known examples that you know are correct, that you can compare your original function to, and then step 3, make improvements on that, optimize that, that model based on those data sets. And so a really good example of what machine learning can be is Google's reCAPTCHA, or CAPTCHA. And the first iteration of this was just a text CAPTCHA, where basically there was some some data, or some files and some books, PDFs and whatnot, that there wasn't really a good algorithm to be able to go through those articles and be able to find the text and identify the text and understand what the text is saying. So they developed a machine learning algorithm that would be able to do that, and then that second, an error function, the second pillar is what the humans, the reCAPTCHA, were really doing in writing out what the text said, basically. And then the second iteration of CAPTCHA was Google Photos, where it was that just identify the photo with like mountains, in this case, or flowers or whatever. And basically what that turned into was, again, that error function identifying, correcting the model. And then this turned into being able to identify photos. So like when you go into like Google Photos or whatever, and you can type in flowers and you'll be able to find that. And then like the third example of reCAPTCHA was just it's the same thing really, it's just now they're doing it for traffic lights and stop signs and cars and stuff like that. And what they're theorizing is that this is for machine learning for cars, for self-driving cars, basically. So let's go into what the data set looked like. So when you open up this data set, you'll see that there's several thousands of files, hundreds of thousands of files, really. And these are all blogs from like 2004. So it's an extremely large data set. I didn't end up using the entire data set, but it's still useful to have. So if we open up one of the files, we'll see that basically there's a lot of stuff in here that isn't really, won't help us identify the author. So the first thing you'll notice is how the layout of the files. There's post, data, post. If you go to the way top of the file, you'll also see that there's a title indication. And so what we care most about is, the post in here. We also care about the date, but not really as much. So we need to be able to parse through this this file, and then be able to find the post identifier, be able to read through all this, and then see another post identifier, and either stop reading or put it into a different file or variable. Yeah. Oh, and the other thing that you're going to notice is that a lot of these files have a lot of weird things in them that, again, aren't going to be able to help you identify the author, like the URL here. There's also weird stuff like this, where it's like it's not able to identify what it is, and that's an indication that they're using a different encoding than what's natively supported, which in Python is UTF-8, I believe. And then you'll also notice that there's a lot of URLs and white space, and both of those are things you're going to want to take out. So let's go into what the makeup of my project was. So first was just getting metadata out of it. So again, if we go back to what was inside or what the files were, you'll see a lot of first the ID, then the gender, the age, their industry, and then their sign. And so that's all very useful metadata that we can take from the file and then actually plug into the algorithm and use. And so this is just the attributes of the blog that in the end we ended up plugging into the machine learning algorithm. And so that's, the contents of the post, the author, number, gender, age, industry, star sign, date, post, all that kind of stuff. Then this is encoding. This is what I talked about before. This ended up being a pretty difficult issue because there are actually a lot of encodings that you don't really expect. You think that, everything's encoded in one, one type of encoding, but there are actually a bunch of different encodings out there for different languages, for different, just different encodings for whatever reason. And so we have to be able to identify what encoding the file is using, and then decode it, and then re-encode it into something that Python is going to be able to read, which, as I said, is I believe UTF-8. Okay, so reading the file, this is just reading the file. I'm just going through, for all files in the, for file name, and so basically for all the files in the larger directory. We're just going through and reading through all of them. Again, I didn't end up reading through every single file because, even with a small number of files, it takes an extremely long time. So I didn't end up going through all of the files, just a handful of them. And then this is just that part I talked about with navigating the file format, where it says, post, and then date, or I guess I'll show you. Just the post here and then date. You have to be able to, read the key elements of the blog post. And then this is just more post-processing that I talked about, taking out the links, taking out the white spaces, URLs, numbers, all stuff that really doesn't help you in identifying the author. Then the next part, after you're able to actually go through the file and figure everything out and get the contents of the file, you have to be able to go through and you have to be able to pick an estimator. And so fortunately they have a cheat sheet for basically what estimator you're going to want to use. And so let's go through this real quick. So we start out, and so is it greater than 50 samples? Yes. Is it predicting a category? Yes. Is it label data? Fortunately, yes, as we have seen. Is it less than 100K samples? Yes. So really we have a choice of two different types of estimators, and that's Knifebase and linear SVC. I've tried both of them, but I found that Knifebase is really the only one that's going to work here. And so what is that? So Knifebase is essentially saying that, so this is the equation for Knifebase, but fortunately, because this is Python, you can use imports. You don't have to model this equation in Python because that would be extremely difficult. And so in the end, you end up just plugging it into the machine learning program, and that's basically all you do. But what Knifebase is essentially saying is, let's say, for example, you have an apple and an orange. Knifebase is first going to look at that apple, and it's going to notice that it's about 3 inches wide, it's red, it has a stem. It's going to be like, all right. And then it's going to look at that orange and going to say, okay, it's also 3 inches wide, it's orange, and it does not have a stem. So I'm going to say that there is a 33% chance that that orange is actually an apple. And all that is to say is basically it takes all attributes as independent, which, is why they call it naive, because, an orange obviously isn't an apple. Just because, an orange is about the same size as an apple does not mean, there's any likelihood that an orange is an apple, but it's still a very good, very good equation or estimator for this current data set. So I'm going to go into, there we go, the file, and I'm just going to run it. But and so we run this file, and it's actually going to take an extremely long time to run. So fortunately, I have some data from a previous results. And so if we look at this, we can see that there's a pretty normal distribution, followed by one outlier. And going off of this, from this normal distribution, we can tell that it's a pretty accurate estimation or prediction, because that one outlier ends up corresponding with the original file name. So basically, that's all to say is that my machine learning algorithm works from what I'm able to tell, and all is well. All right, so let's talk a little bit more about a couple of things. Number one is just what's the impact of this project? What's the result? And number one, it's author identification. But I think the greater impact of this project is kind of showing people that as Moore's laws continues to be a reality, and as processor speed increases and all that, and as supercomputers become a reality, people's it's actually going to come at a cost of those people's anonymity on the internet, because stuff like this is already out there, where basically you're going to be able to run a file, and based on a person's earlier work, they're going to be able to identify you, based on other things you put out on the internet without your knowledge, consent, or really anything like that. And so I think that's one thing that's really illustrated by this project is how the ways you can be identified without even ever really putting your name out there, just being associated with your writing style and stuff like that. And then what's something that I wish I would have implemented on this project or improved? It's several things. I think one of them would be performance. Right now, just to run this program on a really small subset of files, it takes a very long time. Running it on the entire database it would take all day, really. So like right now, it's a single threaded program, and so that's really hindering performance greatly. So I would definitely work on that. Maybe use like the GPU or something like that. So it's like there's some other implementations that I've seen that use like TensorFlow, and that uses the GPU. So I think using something like that would actually be super interesting. I don't know exactly how feasible that is, but I know at least I could make it less of a single threaded application for sure. And then the other thing would be just the identification. I think that I could have used, like right now, it's identifying mainly a lot on metadata, and then also a little also on just the contents, but it's kind of just using basically the words. It's kind of just, it's not like, all I'm trying to say is like it's not a super smart algorithm, because it just uses kind of the words inside. It doesn't have much rhyme or reason to how it's matching in a way, because it's just like it uses this specific word this specific amount of times and all that. So it's not super smart. I think one thing I could do is I could implement like one would be like if you say a word, a new word, like how many times you say a completely separate word, and so that's kind of an indication of how large someone's vocabulary is. If they if they don't fall back on a small subset of words, and they have a greater dictionary and a greater, specifically what hasn't been implemented is how many times they use a new word that they haven't used before. And so yeah.